My chemical equation is the combination of calcium chloride and lithium oxide into calcium oxide and lithium chloride. This is the chemical equation for my reaction. When analyzing this chemical reaction, the first things that you want to look at are the elements that make it up. In this case, the elements are chlorine, calcium, lithium, and oxygen. First off, I'll be analyzing chlorine. Chlorine is located in group 17, period 3 of the periodic table, making it a halogen. For the element chlorine, the atomic number is 17, while the average atomic mass is 35.45. This is the electron configuration of chlorine. The next element that you want to analyze is calcium. Calcium is located in group 2, period 4 of the periodic table, making it an alkaline earth metal. For the element calcium, the atomic number is 20, while the average atomic mass is 40.8. This is the electron configuration of calcium. The next element that we want to analyze is lithium. Lithium is located in group 1, period 2 of the periodic table, making it an alkali. For the element lithium, the atomic number is 3, while the average atomic mass is 6.494. This is the electron configuration of lithium. The last element that we want to analyze is oxygen. Oxygen is located in group 16, period 2 of the periodic table, making it a chalcogen. For the element oxygen, the atomic number is 8, while the average atomic mass is 16. This is the electron configuration of oxygen. The next thing that you're going to want to find while analyzing this chemical equation is a balanced equation. For this chemical equation, it was relatively easy to balance. It turns out, in order to balance it, all that you had to do was add a coefficient of 2 in front of lithium chloride in order for both the reactants and the products to be exactly the same. The reason the number of products has to be the same as the number of reactants is because the law of conservation of matter states that matter cannot be created or destroyed. So in the transition from reactant to product, matter cannot just be lost, it has to be transferred, meaning the amount of matter on both sides of the equation has to be exactly the same. Next, for this problem, we were asked to calculate the enthalpy from the reaction. For this, we first had to find the enthalpy values for each individual chemical for the reactants and the products. The enthalpy values are listed here. After we find these values, we plug these in for the products and the reactants. We then solve using the equation enthalpy is equal to reactants minus products. Using this, we can see that the enthalpy of our reaction was negative 59.2 kilojoules per mole. Because this is negative, it is an exothermic reaction, so it loses heat energy. We are then asked what the total energy released if 250 moles of the product is produced. For that, we then multiplied the enthalpy of a reaction by 250. We are then asked to find the change in temperature of 1 kilogram of water that is at 21 degrees Celsius. First, we had to find the energy of the water in the liquid form, which is listed here. Then we had to find the latent heat of vaporization, which is here. We then added these values together and added them to the energy released in the reaction, which we solved for before. You then use this to solve for the change of temperature, which is the last step. We then add on 79 degrees, which is the change that it had to go through in order for it to go from a liquid to a gas. We can see that the end change of temperature is 6,214 degrees Celsius.